Right, let's continue because just now we just stopped here. So the changes or the difference between 2D and 3D lies in their acquisition, design, or and also the processing. So in 2D, this is examples in 2D where you can only have one lines and few receivers. So but in 3D, as example, this is for 3D marine, you are going to have at least two sources, and then you are going to have sail lines. So let's say these two sources are attached to 4 sail lines, and each of the sail lines you are going to have like few hundreds, or minimum gonna be like 48 receivers, or we call it 48 channels in acquisition term. So don't be confused on your clastic channels or sedimentary channels. So this is the channels or the receivers. So when the boat tow throughout the sea, on the sea, it will go to something like this. So the boat will move in this direction, and then it will go to make a hook or a loop. So it's gonna be like this, and the loop that they are making is going to be the point where they correlate the data to become a cross line. So the cross line, actually we did not really acquire the data for the cross line, but we use a processing technique to correlate the data at the same particular point at the receiver, and then we combine it to become a cross line. So the difference is in the target. The image area gonna be better, the depth is gonna be improved, the measurement for the depth, velocity, thickness, and so on is gonna be improved in 3D data. And this is actually there is an operational unit or department that is specialized in charge of 3D acquisition. So it's very interesting. You're going to work on the ship or on the vibrators if you are working for survey design. So definition of 3D terms, basically you're gonna have this is for processing usually, but as a seismic interpreter you need to know this term. So the cross line is the direction that is orthogonal to the receiver lines. So these things. Sampling in this direction is generally weak and has to be investigated carefully. Remember, we did not acquire the data in cross line. For the cross line, we actually combine our data to be in the cross line direction. So inline direction is parallel to the receiver, and usually it is the deep line. And sampling in this direction is generally satisfactory, very good. And in a 3D processing, you have to create a bin. Bin is like a box or a house where your traces are going to be stored in these houses or this bin. It's not a dustbin or something, okay? And CMP bin is known as the common midpoint bin. It's a square or an area, as explained there, which contains all the midpoints data correspond to the same common midpoint or common location. So traces that fall in the same bin will be stacked, and the stack is the seismic that you are seeing, the one that we keep on interpreting the inline and crossline directions. So they are the stack, and their number in the bin is correspond to the fold of the bin. So fold of the bin, fold is not something like a folding, like anticline or syncline like this, but actually fold in terms of acquisition refers to the number of traces that has been stored in a particular area, in a particular bin size. And the larger the fold, the better the image for that particular location or particular zone. So a bin size is correspond to the length and the width of the bin. So the smallest bin dimension are equal to half source point interval. So I'm sure you have learned this in seismic methods, right? So this is just kind of a revision for you. So in 3D data, how we view it, we have a time slice, we have a vertical section. Sometimes I refer this to a cross sections because it's really a cross sections. You're going to see all the faults and all the reflectors. So you see these yellow lines, they are actually the horizons that interpreted at that almost 1.5 second, and this is corresponding to this. So actually you are seeing things on top and seeing at the side view. So when you see the real data, it's very easy and very fascinating. So this is how we view it. This is example of our data in the Northern Sea. Is known as a chair display, a common display that is very interesting, where you can see the directions of the inlines, the data in here, and how does it connected to the other side of the data, where you can see the continuation of these reflectors, and you can see how does it shown in the top view. So you can see the faces are distributed. It's kind of like maybe a channel perhaps. So this is how a cartoon showing how we can utilize 3D seismic data from different perspectives. You can cut it here, you can cut it here, or doing some orthogonal, some zigzags. These are the diagonal or arbitrary lines. You can see on the time slice, you can see on the horizons that you pick, you can create a surface, a fault surface, a horizon surface, and you can actually view the whole data in all domains. So that's why you require a good workstation. This is the example. You can see things in diagonals, in cross line, in inline, in time slice. This is example from Petrel. So for 3D, you can still work with 2D. It means you can still work in 2D domain. So this is a 2D domain. For a 3D data, in interpretation window, you can pick the faults, you can pick the horizons, you can predict the next picking area, picking location for the same horizon. And this is a multi-window interpretation where you can check your interpretation on this particular line, which is shown as this yellow straight line here, and you can actually double check it on a 3D view. So you can combine your interpretation in one 3D window. You can see everything. You can see what you have picked, what you haven't picked, and so on. And you can see them correlated in the inline and cross-line directions. This is another example of showing multi-seismic data in 3D window. You can combine seismic volume of this area and the other area. And you can put in different colors, so they are very interesting. And you can actually draw the interested area that you would like to connect. So these points that are curving here is shown here. So you can actually see them, like perhaps you have one well here and you have one well here. So you want, and you have another well here. So you would like to connect your 3 wells. That is very good and very interesting to do for 3D data, but you cannot do this in 2D data. Means in 2D data it's more to you extrapolate, you imagine, but here it's really real. So why 3D? In the applied aspects I have mentioned here, is better in imaging, provide new reserve, give fewer dry marginal exploration well, optimize the number of the production wells, and we can rejuvenate on the old fields, and we can have a good appraisal or development planning. We can improve the field management or lifetime of the field. So this is examples in 1976 where we have in to 1994 where we have increase in the 3D and increase in the oil volume found. You can see a better success rate. We have fewer dry holes when we have 3D data. You have, this is result from Gulf of Mexico. You see when we start drilling based on 3D in around early 1990s, then you have a better production increase. Because in 1975 to 1980, you have a very good production, but it drops drastically because your well are dry, you cannot find new reserve through 2D. So they start 3D acquisition in around 1987, something like that, and they increase the production after that. So this is showing a high success rate where we made a survey. 3D has significantly improved your drilling success rate. So many people agrees, and an interpreter needs to have a formal training in geophysics to work with 3D. This is so true because, to be honest, I trained myself. So I didn't have a formal training rather like going to a course or something, but it is very crucial for you to attend or to at least have a tutorial to help you, because we need to use the software. And I need to integrate my interpretation with the geologic and engineering data for best results. So like more than 100 people agree to this. It's really that you don't have, for working with 3D data or with seismic, you need to have not just geology, but also geophysics, computer knowledge. You need to have a bit up to date on the current techniques and current progress of the software. So you have to be all aware. So 3D seismic data is a key success for a good quality data to have a better accurate database, involve multidisciplines integrations from the beginning of the acquisition to the planning of the reservoir. You're going to have a clear understanding and capabilities, and you also need to be aware on the limitations of the softwares that you are using, and you're going to have geological knowledge and skills beyond the geology to apply them to the seismic interpretation. So we have some time constraint, like sometimes you don't have time and depth information because you have to convert from time to depth. You don't have sonic data, you have a poor quality seismic, you have little information on the acquisition, you don't know the geology of the area, you don't know the engineering of input from your reservoir engineer, and sometimes you have limitations on the software and hardware, which is maybe your computer is not powerful enough, your data is too big, and so on. So before we end, I have provided 2 slides saying like a general dictionary for you to have an idea the terms and things that we use for seismic, like the wavelet, what is event, what is time slice, and so on. So this is for your referencing. And actually, before we end, I would like to share with you the good book or reference book. So this is the guru for 3D seismic data. It is very thick, it's available in the libraries, and I really like it. It's a bit outdated, but all the informations are really comprehensive. So, and it has beyond the seismic interpretation, you have seismic attributes in it. And another, my favorite book is this one. It's from EAGE book, the store book, their bookstore. And what I like is the first chapter, which is the introduction. Is about how you see your sedimentology in the geophysics data. It's really showing how the analysis has been done and so on. So I'm not sure if this is available in the library or not, but you can go to EAGE website and have a look on it. You can also come and borrow it from me, but if I only have 1 copy, maybe we can make some photocopy or something for that particular chapter. So I think that's all for now. We are going to review our lecture later when we decide on the time and date for our real one-to-one lecture, face-to-face lecture. But for now, please listen to this video, try to understand it, and we are going to have a bit of assessment after this. So that's all, and I hope this video benefits you. Okay, bye, and assalamualaikum, and have a good day.